Okay, here's my example. Here's my plane down here. So we're going to use projections to find this point, which I'll call Q. But first, let's start with the point P. Let's say here. So again, not meant to be an accurate picture, just meant to help us think about what we're doing. So we'll put Q on the plane there. So this point here, I'm calling Q. So my technique is to form a triangle and do a projection. So what I'll do is I'll take a point, any point that I know is on this plane. And I'll call it P, P naught. So I need to choose something here, and it does not matter which one I choose. So I need to choose some combination X, Y, Z that passes this test. First thing that pops to my mind is P naught can be 1600. Okay. So what we're going to do is we have a triangle here. Now we want to do a projection in order to find this side length here. So first thing is we will form a vector from P naught to P, like so. And then the triangle goes like this. Ooh, that's a wavy line. And then Q is the closest point to P, so there's a right angle right there. So we want to do a projection. So we'll do the vector from P0 to P, and we'll call that vector U. So this vector I'll call U. So U is the vector from P naught to P, which I can find by subtracting the vectors corresponding to P and P naught. So that is, what is that? 317 minus 1600. So I get, what do I get? Minus 13. 1, 7. Now my trick will be to use the normal vector for this plane. So let's draw the origin. Whatever, it doesn't matter. Just let's say that the origin is over here. And then my vector, my normal vector for the plane, for this plane, is going to be pointing, we'll say straight up. Normal straight up. We'll say it goes like, let's see, maybe a little bit longer, like so. And the normal vector for this plane is given by this is called the normal equation sometimes. So we just take these coefficients, 1, 2, 1, or negative 1 rather. So nice thing about that equation is the normal vector is right there. Okay, so what we're going to do is we're going to take this normal vector, which is for now situated at the origin. We're going to grab it and we're going to move it to the origin. No, move it to the point P naught. So let's take, well, I'll just grab it, move it here. Oh dear, it's not what I want to do. So I'm going to grab it, move it over, and put it so its base is at P naught. Now what's the point of all this? Well, the point of all this is that if I'm interested in this side length here, I can find it by projecting green onto red. So what that looks like is I got this rectangle floating in space here. Oh, when I put my arm that way, I get all shaky. Upper body strength. Okay, so it's this vector here, which is the same as the vector QP. Okay, so again, if I project U, the green vector, onto the red vector, what I'm going to get is actually the vector QP. Let's write that down. QP, this vector I'm certainly interested in, is equal to the projection onto the normal of U. Okay, so I've got U and N here, so I can just use those to find my projection. So I get U dot N over N dot N in the direction of N. Forgive me for not putting the arrows on top. I don't feel like it. Minus 13 plus 2 minus 7 over N dot N 6 in the direction of N 1, 2, minus 1. That is minus 3. So I get this vector minus 3 minus 6 plus 3. And this is the vector QP. So if this is QP, that means that I can find the corresponding vector Q, because it's going to be, remember when you have this vector connecting 2 points, it's the subtraction of the corresponding vectors. So if I solve for Q, I get Q is going to be P minus this vector. Now what's P again? 317? P is 317, yes. So working this out, I get 6, 7, 4. So my conclusion is that this point that I'm interested in is 6, 7, 4. And the distance I can find is, the distance I want is the length. Let's go back to the picture. The distance I want is this. Orange. This distance is the length of QP. So I can find that just by noting that QP is given here. So the distance is length of QP, which is the length of -3, -6, 3, and I factor out a 3 to make my life easy, easy, easy. 3, and that's root 1 plus 4 plus 1. That's 3 root 6 is my distance.